This question, we're given the equation x squared equals negative 10y, which is an equation of a parabola, and we're asked to find the vertex, the focus, the directrix, and a graph. So what do we know? We know this is of the form x squared equals 4py, where p is the directed distance from the vertex. So what does that mean? Well, the vertex is going to be at 0, 0. There's no shifting. It's x minus h squared equals negative 10, y minus k. There's no shifting. It's x minus 0, y minus 0. So the vertex here will be 0, 0. Now, how do we find p? What we have currently is we have x squared equals negative 10y, so 4p equals negative 10. So p is negative 10 fourths, or negative 5 halves. Now we need to visualize what's happening here. What is our case? X squared equals 4py. That's either an opening upwards parabola or an opening downwards parabola. If it's a y squared equals 4px, opening left, opening right. So in this situation, p is positive. In this situation, p is negative. So we know this is the sort of graph we're going to have, and the vertex is going to be here. Remember, the directed distance, p is the directed distance from the vertex. The vertex is 0, 0. We need to go down 5 halves from the vertex to get the focus. So let's jump to our graph. And we will erase what was there before. So our vertex is 0, 0. P is negative 5 halves, and it's an x squared one, so it's either opening upwards or opening downwards. Since p is negative, it's opening downwards. So I have to go down that distance p. P was what? P was negative 5 halves. So what I need for my vertex is 0, focus. 0, negative 5 halves will be the focus. My equation that they gave us, the equation was x squared equals negative 10y. So again, you can see that the parabola goes around the vertex, encompasses, the parabola goes around the focus. It encompasses the focus. The focus is in the interior of the parabola. Now, the parabola is a set of points equidistant from the focus and the directrix. So this is 2.5 away here. I need to go 2.5 that way. So 2.5 that way would be through this point. A horizontal line would be at y equals 5 halves. That will be our directrix. Now, can I find some points on this parabola to make it a little easier for me to draw it by hand if I were doing that? So if I didn't have this graph, if I just had this, I would say, well, if I go 5 halves, double 5 halves, 5 halves and 5 halves, that's 10 halves. If I go to 5 here, that point would be what? That point would be x is 5, y is negative 5 halves. We see that point? So notice, how far is it from the focus? 5 halves and another 5 halves, 5 units away. How far is it from the directrix? 5 halves and another 5 halves, 5 units away. So this point is double p from the focus, double p from the directrix. Going back the other way, that would be at negative 5 halves. And again, those 2 points sit on what we call the lattice rectum. So if you want to construct this graph starting with this vertex and those points on the lattice rectum, that will give you an idea of what that graph should look like. And then we can see that indeed it goes through that. So we have the vertex. What is the vertex? The vertex is 0, 0. We have the focus. What is the focus? 0, -5/2. The equation of the directrix. The equation of the directrix is y equals -5/2. The graph, certainly Desmos gives us the graph, but it's helpful to find a couple extra points on the graph. These 2 points lie in what we call the lattice rectum to go ahead and enable us to construct the graph if we were doing it by hand.